All right, you guys, we have our first test next week, right? And I'm gonna let Lindsay make an announcement about study group. First, I wanna say two things. Sorry. My brain, like if I don't say it, I'm gonna forget it, then I'm gonna be like, what's he saying? And I want you to either validate or reject what I'm about to say. Most professors obviously don't wear Crocs in their shirts inside out there. But most professors usually start off the semester with a hard exam. Usually their first exams are hard because they kind of want everybody to fall in line and refocus and that kind of stuff. I'm not about that life. It's not to say my first test is I make it purposefully easy, but I like to, we're kinesiology majors. I look at it more as periodization, right? Like you start off, it's a new language, it's a new world, it's a new style, and then it actually gets gradually more complex because you're able to do more with that knowledge, okay? So the reason I'm telling you this is I expect the first test to be solid, to be good. I think the class average should be a B. But when you get that grade back, don't just cruise. Don't just say, oh, it's all going to be easy from here. Again, I think Lindsay can attest. It's, now that we can speak the language, we can do more complex things with it. Okay, so I just want to give you that heads up. Lindsay, come up, make your announcement.
They just have a review session. So I have class until 2:30, so I'll probably come back here after that. And then we'll have a little review session if anybody has any questions or wants to ask like anything or just go over a few things. Like if y'all have been practicing and y'all have practice examples, we can go over that, something like that, and then for the test stuff.
And where's it going to be?
It's going to be in the step lab.
In the step lab. Awesome. At 2 o'clock?
Probably
like 2:30. Sorry, that's what I meant. All right, BYOB, right? Bring your own books. All right, you guys. So what I want to do is really fine tune, like almost kind of like a pre-review, fine tune a few things, and then by the end of today, we should be good to go. And again, on Friday, I'll start lecturing on new content. Friday's lecture, this is what I love about the way the class is set up. If you're in it and you're like, I got it, come to Friday, it's not going to mess, it's only going to reinforce your understanding for the test, even though I'm not asking you ankle and subtalar joint questions. But if you're the kind of learner that's like, I can only take in this, then just watch it after the exam and catch back up with it, right? So it gives everybody those options. All right, guys, your commandments, your kinesiology commandments, we don't assume. That doesn't mean that doesn't mean you have to overthink. Don't assume doesn't mean overthink. That just means that if you have a math problem that has a bunch of numbers, I'm just going to take my time and do the process to make sure I get the right answer. So don't assume isn't meant to make you overthink. It's just utilize your tools to make sure you see what is there. That's all it is, okay? We rotate to translate. Why that's important is human motion is a combination of rotation and translation that we call general motion. We do not want to communicate motion with linear translatory things, right? We don't want to say flexion is arm go forward because sometimes flexion arm goes down. And sometimes if you keep flexing, arm goes up and arm goes back. In the rotational concepts, things are constantly changing linearly, but they're consistently rotating the same way. You can only spin two different ways. So joint motions in our body are from the perspective of the spin, not the shift, okay? So that's important about that. Well, joints rotate in planes and about axes. Joints can't translate by themselves. That's called dislocation when we have joint translations, okay? So we rotate in planes and we rotate about axis. This is a good example of do not assume. On the test, I'm going to ask you, what axis is this rotation happening in? And it's frontal plane, but it's anterior posterior axis. So if I ask you an axis question, give me an axis answer. Given a Caesar, what is Caesar's? If I ask you about plane, give me a plane. If I ask you about axis, give me an axis. And this is what, for me, this is why I think your scratch sheets can be tools to help you not assume and to not make careless mistakes. That's why you have scratch paper. Okay, so if I ask you for an axis, give me an axis. If I ask you for a plane, give me a plane. We analyze motion joint by joint. That just means you can have something that have multiple motions in multiple areas and it looks overwhelming. But the reality is all of that crazy stuff is happening in very specific places that can only do very specific things. Keep it simple. So even though I might be moving my shoulders and my knees, and if I'm just asking you about the wrist, none of that other stuff matters. None of that other stuff matters for that question. None of that other stuff happens to your analyzation. If I'm asking you about the right knee, the left knee doesn't matter. You analyze motion joint by joint to make it simple, to make the process easier. Lindsay, back me up on this. Number 5 is one that students, it takes you a while to get on the bike. Position is where you're at, motion is where you're going or how you're moving. So my wrist position is flexed, but that doesn't mean I'm flexing or extending. It's just my joint position. Position is relative to anatomical. Where are you at is relative to anatomical. Where are you going? For this first test, sagittal plane stuff is in reference to fetal. Think about it. Are you getting into fetal or are you going away from fetal? Position, anatomical, motion, fetal. Are you going towards or away from fetal? That's obviously, we talked about it, 7, 8, 9, 10, that's third test up, right? So for your first test, I'd say 6, 1, 2, 3, 4, 5, and 6. You can power. That's right, Gandalf. All right, we did all of this, rotate to translate, did all of this. I want to emphasize this. Just want to emphasize, human motion is a little weird and different, and that's okay. In engineering, in the real world, the door always moves about the wall. The small piece always moves about the big piece, but that's not how it works in the human body. We can move big pieces about small pieces. And so for us, doesn't this make sense? If you start in Lafayette, no matter how you get there, if you end in Lake Charles, you had to travel west. Meaning, it doesn't matter if the small piece moved about the earth or if somehow magically you stayed still and the earth rotated the other way, you still moved in the same place. So we have to call it the same thing. So we are always used to the hand moving about the clock. And so we say clockwise and counterclockwise. But in the human body, the clock can move about the clock hand. And they have different rotations globally, but the same rotations locally. Meaning, from here to there, we would say rotation of 90 degrees clockwise. But that is the exact same motion as from here to there, because it gets me to the same place. Does that make sense? And an example of that is, from here to there is the exact same as from here to there, even though the spins might look different. Here to there is the same local rotation as from here to there, even though the spins might look different. For our second test, it's going to be, say, more tricky, but once you understand this concept, from here to there is the same spin as from here to there. Even though my head spun that way and the other one, my body spun this way, it's the same relative change in spin. I think in class, I said, you can open your bottle by spinning the cap lefty-loosey or spinning the bottle righty-loosey. It's going to open it the same. It's going to have the same relative spin. Does that make sense? Okay. That's why it's so important for the process. Where did you start? Where did you finish? How did you have to move to get there? Start, finish. I had to have bilateral shoulder extension. Start, finish. I had to have bilateral shoulder extension. Make sense? We rotate because if all we did was translate, we would have some very bad days. We could have a lot of dislocation. All right. What about planes and axes? Let's do some planes and axes practice. So your joint motions are going to be sagittal. But I can ask you frontal transverse in terms of just the concept of the plane and the axis. Does that make sense? So in other words, I 100% could say, is this frontal, sagittal, or transverse? And if it's global, you know that it's from the room's perspective of spin. In other words, this is always going to be the front and the back of class. Anterior, posterior axis. Frontal plane rotations occur about it. The sides of class, bilateral. Sagittal is going to always be about it. Poles, top to bottom. Transverse is always going to be about it. Local or relative is from the person who's moving's perspective. So in other words, if I'm here and I say, what plane are my shoulders rotating in? It's sagittal from the room's perspective and my perspective. That's cool. But if I do this, now we're not seeing the same thing. And that's okay as long as I communicate what perspective is out. If on the test I say my shoulders are moving in what global plane, it's the room's frontal plane. You see frontal. Even though I see sagittal. Guys, that's okay. That's like having an opinion. I like the movie. I didn't like the movie. It's okay. As long as you're communicating that it was your opinion. Planes and axes have global fixed references so that everybody can see the same thing, and then they have local references, and our joint motions are local in reference. This is my elbow sagittal plane. This is still my elbow sagittal plane. This is still my elbow sagittal plane. You know why? Because this is still the inside of my elbow, and this is still the outside of my elbow. Side to side, bilateral axis. Sagittal plane. It's still the medial epicondyle, it's still the lateral epicondyle. So still the medial collateral ligament, still the lateral collateral ligament. Inside, outside, side, side. So as my elbow moves globally, the planes and axes of my elbow move with it to keep it local. Does that make sense?
So essentially saying, you know, the same thing. From a global perspective, which you have in this life, you basically, you talking about a classroom, right?
Mm-hmm.
And you talk about local, in essentially like, from our eyes.
Absolutely. Yeah. So on the test, if I say global is like an absolute, right? You and I might point differently if I say point to your right, but we would point the same way if I say point north. We have the same, yeah. It didn't matter if we're looking at each other. You point right, I point right, but if we say point north, we're all pointing the same way, regardless of where we are. And global references are going to be used in, you know, reach back, reach up. It's not to say global references are bad. It's just to teach you that they are limited. They're limited, yeah. They're limited. And a lot of times our illusions get caught up between the blending of local and global. I think I gave this example last class. If I'm trying to look at someone's shoulder motion, what I don't want to do is say, arm, go up as high as you can, and then they do this, and I say, oh, I'll give you a better example. Where are my baseball, softball players? Have you ever heard of someone throwing overhead, right, or sidearm, right, those kind of cliches? When someone's throwing overhead, it's not that their shoulder is here. It's that their body is leaning, they're still throwing side, they're still throwing from the side, but their trunk lean is so that the hand is globally overhead. But locally, everybody's pulling the same, whether you're here, whether you're here, whether you're here, or whether you're here. So that's an example of a global reference versus a local reference. And a lot of times those global references supersede our brains into looking at things locally from the perspective of the person. So I think a good summary is the elbow can flex and extend in all three global planes. I can flex in the room sagittal, I can flex in the room's frontal, and I can flex in the room's transverse. But if I interviewed my elbow and I said, hey elbow, how many planes did you flex and extend in? The elbow's like, that makes sense? Question? What you got? Oh, okay. Does that make sense? My shoulder can rotate in all three planes globally. For my shoulder, it was doing, shoulders like I was doing the exact same thing. All right, let's do some more practice. Plane, global reference, okay? You like getting up to come to 7:30 class? What plane was that spin? Notice I didn't ask you the name of the spin. That's not the point. It's to be able to see planes and axes, okay? What plane did that happen in globally? Transverse. Some people, and Lindsay, I want to see how you see it. Some people see the spin and then you can tell the axis. Some people see the axis and then you can tell the spin. So in other words, if I'm here, I see it as how am I spinning? Am I transverse? Am I sagittal? Am I frontal? But some people see it the other way, and it doesn't matter. It's two different forms of the same thing. It's, do I see the axis about which it's spinning about? Hey, that's a polar axis, so therefore the spin has to be transverse. Hey, that's an anterior-posterior axis, therefore the spin has to be frontal. Hey, that's a side-to-side bilateral axis, therefore the spin has to be sagittal. Lindsay, how do you see it?
I normally see that point as
Uh-huh.
so I see that.
I'll see it. So do they. What's cool is that those concepts of planes and axes they're married concepts, and the divorce rate is 0. Meaning sagittal plane spins have to happen about side-to-side axis, locally or global. Frontal plane spins have to happen about an anterior-posterior axis. You can't have, that would be like this. Who says you need fancy equipment? Good thing, because we can't afford it. Check this out. Anterior-posterior axis, yeah? I can't spin the paper like this. I can't spin the paper in the transverse, and I can't spin the paper in the frontal. I can only spin it perpendicular to the axis. And if I move the axis, now I have a polar, I can only spin it transversely. I can't do it sagittally, and I can't do it frontally. Does that make sense? And if I have a side-to-side, I can't spin it frontally, and I can't spin it transversely. I can only spin it sagittally. The planes and the axes, the spin and what it's spinning about, your tires can only spin about their bilateral axis. The tires can't spin like this, and they can't spin like this. They can only spin perpendicular to the axis. And if the axis changes, so doth the plane has to change with it. It has to. So in other words, you can't have frontal plane rotation that's about a polar axis. That wouldn't happen. You can't. You literally can't. showed you here. Okay. All right, how about this one? Global reference. This is when you're saying you don't like 7:30 class, but you also believe in flexibility. You're stretching. Maybe some of you see axis. Maybe some of you see plane and then see axis. But from a global reference, the room's perspective, how was my head spinning? Frontal. Good. Because I told you whose opinion I wanted. It might have been my transverse, but I didn't ask you for my opinion. Does that make sense? And I have to give you the opinion on the test, unless there's one example or one exception where I don't have to ask you, and that's if they're both seeing the same thing, right? In other words, if I'm here and I do this, the room and myself are seeing the same thing. Or if I'm here and I do this, sagittal is both local and global. So on the test, it's inevitable. I'm going to get a lot of questions. Like, it's all part of the game. I've been doing this for 20 years. But I'll just politely say there's enough information there for you to be able to answer. Or if there's not, I'll make mistakes. I might look at it and say, oh, thank you for bringing that up. I'll go add something. But again, I've been doing this for a long time. Those are rare.
Some of my sagittal planes is short question. Stuff like that.
Well, so to clarify, for your test, the joint motions you're accountable for are going to be only things in the body that flex and extend only. The ankle has two different forms of flexion. I'm going to do that on Friday. The knee has flexion and extension in the knee sagittal. The hip has flexion and extension in the hip sagittal. Yes, the hip has other stuff, but that's for the next test. The trunk has flexion and extension in its sagittal. The cervical has flexion and extension in its sagittal. The wrist has flexion and extension in its sagittal. Elbow has flexion and extension in its sagittal, and the shoulder has flexion and extension. Now, that doesn't mean, again, I think that's a great question. That doesn't mean I can't flex and extend in the room's frontal, but it's still flexion and extension because it's still in the shoulder sagittal. Flexion gets you closer to fetal. All of the joint motions that I'm going to teach you, are there changes in angles? Absolutely. But angles can be absolute and angles can be relative. So I'm going to teach you how to see motions based off of purpose so that it's not as confusing as, well, whoa, I'm decreasing this one, but I'm increasing this one. Or if I rotate my radial on a joint like this, whoa, isn't this the same? It's the same here, isn't it the same there? No, because this is getting me further from fetal, and this is getting me closer to fetal. Flexion gets you in a fetal. So that's how I'm going to teach you all these complex lateral, medial rotations, knee rotations, inverse. It's going to be purpose. And with purpose comes consistency, because there's no exceptions and there's no confusing angles. The anterior one decreases for flexion, but the posterior one decreases for flexion. You know what they have in common? They both help get you in the feet. Flexion gets you in the feet. All right, how about a couple more? All right. This will be a plane axis question, and it'll also help us to practice identifying solids, okay? So on the test, I'm not going to ask you about ab and adduction on the first test, but I can say what plane and axis this is happening at global. So let's do that question, okay? From here, you observe this. I would love for you to tell me the planes and the axes at both of my shoulders, globally, global reference. You see how it could be a distraction, right? So what you do is you say, well, man, there's too much happening. Let me just start with the shoulder and ignore the other one. Let me figure that one out. And then after I'm done with that, I'm going to ignore that one. And and then go to the other. Make sense? I want everybody to have a chance to give it some thought. But when I ask for that, I'm going to come right to you. So give it some thought, okay? Practice analytical thinking, which is something I think we need to do more of for you guys, because when you get out in the real world working with clients, you're going to have to think analytically. Not every problem is going to be in a cook book. Who has any family member who's a really good cook? Anybody? My dad? No, it'd be insulting to use some kind of recipe. This is how my dad cooks. Oh, I know what it needs. Right? Got to think analytically. Planes and axes, both shoulders. 10 more seconds, then we'll roll. Give me one shoulder. Which one, right or left? All right. Okay, what the right do? What plane is the right one in?
Second.
Good, good, absolutely. My right, not your right. You can see how easy that would be. Amputate right on. Okay? Oops. What axis? Outstanding. Sagittal plane spins, always about bilateral. How many of, and again, it doesn't matter because we're getting the same answer. We're getting consistent answers. How many of you see axes better first? Good. Side-to-side axis. And I guess the rest of you see plane first. You see the spin and then say, oh, it has to be about the bilateral. Again, it's two different. What I love about this is it allows different learning styles and different brains to be consistent in the right answer. It doesn't matter if you see axis or if you see plane, because it's going to get you to the same place. Right? Who wants to tell me about the left? Did they do the same thing? Outstanding. The room's frontal plane. It's my frontal plane too. But I asked you just about the room, right? So if I'm asking you about a global reference, it doesn't matter what my reference is. Frontal plane about a, well, we had bilateral for the sagittal, so we can't use that one again. So if we hear, if the paper is rotating like this, where would we want to stick the axis? Yeah, front to back, right? This is how we want to. So we want the axis to be here. And that's a great point. I'm glad you brought that up. Because sometimes planes and axes can be super confusing because like, oh, I'm doing a cartwheel in the bilateral. No, you're doing a cartwheel in the frontal about an AP. So that is confusing sometimes. Those axes kind of look like the roads of spin. But they are the point about which the spin is happening about. And you know what's great about what you did? When I asked that question on the test, you're sitting on it and you're gonna crush it. I love it. It's just about clarification, fine-tuning.
Hands on about multiple axes.
Absolutely. 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 So what we're doing right now, do you know the Etch-a-Sketch? What we're doing right now is we're kind of moving one knob. And then I'm saying, okay, now let's move this knob. And then on the second test, we're moving both knobs. And we're going to see how you have frontal, you have sagittal, but I can 100% move in 3 dimensions of motion. And that in itself is confusing unless you have a process. So in linear terms, you know north, south, east, west, but some combination is north, northeast, north, northwest, south, southeast, south, southwest. So it's very similar. All frontal, all sagittal. Well, what's this? A combination of frontal and sagittal. Some of it is here, some of it is there, some of it is about this, some of it is about that. And so the combination of this is really just some of this and some of that. Absolutely. Absolutely. But our Etch-a-Sketch is a cube and we have 3 knobs. We can make it go here, 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 and then that magical third knob. It can make it go up and down. Y'all want a few more practices on planes and axes? Okay. All right, how about this one? What if I, trying to yoink, let me grab this chair. To give you a more complex, remember this isn't about joint motions, this is just about seeing spin, seeing rotation. Global reference. See if I can do this right. Don't mistake my thumb for an axis. My thumb is just a reference to my patella moving. Global reference. I use the thumb rule. This just as a habit to show you. This is going to be second test question. This is actually lateral or external rotation. Too many times people see the lower leg come in, and so they're like, oh, it's coming me or it's coming in. And I use the thumb to show you, no, it's spinning out, it's rolling out. That's going to be second test stuff. All right, what was the plane of whatever you saw? It doesn't matter what we call it, it's just that there was rotation. So what global plane did this rotation happen? Frontal, good, absolutely. Here was the axis. Anybody see that? Frontal plane about an anterior posterior axis. Did you see it? Good. What if I'd have done this? Same motion. I'll do the, be consistent again. What global plane? Sagittal. Now again, you're like, well, why is that important? It's important because even though we had rotations in 2 different global planes, locally to my hip, the hip was doing the same thing, and therefore it's going to be the same motions. You'd be surprised how many students, and again, it's not your fault. I'm your teacher, but I'm also your counselor. Like I'm not trying to reprogram our brains. There's some students who are going to say, I have no problem with flexion and extension. But if I did this, those students are going to say ab and adduction. Because their brains want to make everything global. And I need to reprogram you to say, no, this is still the bilateral axis of the elbow. This is still the inside, and that's still the outside. This is still flexion and extension of the elbow. So that's why it's important to understand global so that we don't fall for the traps that global references have laid out for us. Does that make sense? There's a couple more things I want to get to. That little thing, guys, I don't know if y'all ever heard of it. It's called a CD. You ever heard of that before? A CD? Back in my day. Back in my days, like the set days, 8 tracks. All right, guys, let's take a look at this picture. This is on page 27, bottom right picture. So we have before and afters, but we can also communicate with enough information motion with references to anatomical. What do I mean by that? Well, if you were east of Lafayette, and again, this is going to be home for these analogies because this is where school is. So it's not your personal home. This is where Bushel is. This is where you are. If you just sent me a picture of you in, Lake Charles, and you sent me a picture, like let's say you met one of my favorite athletes. You're like, hey, this is Mom. That's cool. But then I'm like, you have a test in an hour. You better come home. Knowing your position and communicating whether you're coming back or away can infer motion. So in other words, if I'm in a flexed position and all I had was that position, and I say my shoulder starts rotating to go back to anatomical, wouldn't I have to have extension to go back home? That's all I'm saying. Or if I'm in a flexed position and I say my shoulder starts moving away from anatomical, well, yeah, it's already away, but it's only 90 miles away. It could still keep going further and further away. So movement away from anatomical would be shoulder flexion. Going towards would be extension for this example. If I'm in anatomical and I say you move away, well, there's two different ways I could go away because if I'm in Lafayette, I could go on I-10 East or I-10 West to go away from home, right? So extension from, flexion to, flexion from, extension to. We kind of talked about that last class. So there is another way with enough information we can infer motion. One is the classic before and after, and that's going to be most of the questions, the before and after. But another one could be just a position question. So in other words, I have this, and I might say, what's the position of the right shoulder? And you say, it's extended. True. And then the second part of that question would be, what if the shoulder starts rotating back to anatomical? What motion would I have to have? Flexion. Does that make sense? But what I can't do is just give you this picture and say, what motion is happening? None is all I know. But if I give you this one picture and say the shoulder starts moving back to anatomical, and we have to have flexion. Because that's the only way to get back home from here. Here, if she starts rotating her shoulder back to anatomical, it would be extension. Make sense? Lindsay, any feedback on that? While we're here, start to finish. Cervical, left to right, cervical extension, right to left, cervical flexion. What position is the picture on the left? Flexed. Extended. Notice there's no hyper unless it's excessive. Hyper is beyond normal range of motion. That's your normal range of motion. There's nothing hyper about it. It's extension and extended. And when not hyperextending my cervical, it's extension. Trunk, flexed, more in the fetal, right? If the trunk went down, you have extension, it went back to anatomical. It flexed. What about the cervical? Do we have enough information to talk about the position of the cervical? Say that's flexed. You remember that time I gave that question to the person upside down? Oh, that's fun. That's fun. It's very similar. I'll try to find it. Guys, if her cervical was in anatomical, her neck would be here. True? And it has nothing to do with her eyes being level, because eyes being level is a global reference thing. The reason her eyes are level is because her cervical is flexed. I don't know what Miriam is doing right there. Try to get a better position. Good. Position. Good. What about from there to there? Flexion. Good. Specifically, we had flexion to and then flexion from. That's like literally saying I started in Lake Charles, home is Lafayette, and I traveled east to, and then I kept going, and I went east from. Past my exit. Extension to, extension from, flexion to, flexion from. Flexion from, extension from. So I think the reason I had these pictures is because these are classic examples of what you would find like in a textbook. But we need to give them more context. So in other words, a book can only have fixed pictures, unless it's a flip book or QR codes, which we try to incorporate in some of these. So what happens is that traditional textbooks kind of mess with your mind to say, oh, my wrist is in this position, that must be flexion. But the context is you start here and you travel there, and that is flexion. Does that make sense? But they don't give you that. They just give you this position with the inference. And so that's what I tried to do with this bottle, is to give you a better picture of what's actually flexion. From there to there, flexion from, there to there, extension to, extension from, flexion to, flexion from. Make sense? There's 3 positions you can be in for this first test. You can either be flexed, extended, or in anatomical. And then I told you the caveat. There are some joints, your knees, your elbows for this test, that they don't live in Lafayette. Their home is not in Lafayette, where you can travel down I-10 in either direction. They're already at the end of their interstate. So that's why it's okay to say the elbow in its anatomical position is extended, because you can't go any further back. Any more extension is hyper. And that's actually my theory on why students struggle with hyper, because most of the time, the joints that are going to be hyperextended, knees, elbows, it just so happens that their anatomical is extended, so anything further back is hyper. But that doesn't mean my wrist is. It doesn't mean my shoulder is. It doesn't mean my neck is. So I think that's how that confusion gets in, because when your elbow does it, it's hyper. When your knee does it, it's hyper. So then people apply it to all of the rest of the body. Final few minutes of class. How about feedback, questions, things that, who plans on going to the study group at 2:30? Anybody? What's that? Looks like you could have a packed house. I have a theory about that, though. Maybe the students that at 7:30, right? Maybe they're just like, I'm ready to play ball, man. I'm ready for the first game of the season. Enough of this practice. I'm ready for you to serve me up and change up. Guys, I can't change you up. I've told you all I've told you all my change ups. I've told you all my all speed pitches. I've told you what I'm gonna ask, how I'm gonna ask it, and I emphasize which questions students typically miss, and then I told you why they typically miss it. No fooleries. Let me leave you with this. Let me leave you with this. I personally think most students that struggle don't take this material seriously. I'm being honest. And I'll tell you why. Because our whole lives we've been dealing with human movement. And not only that, we've had parents coach us on human movement. We've had coaches coach us on human movement. We've been around this stuff our whole lives. And so for us, it seems familiar. Some students are certified personal trainers. You've been lifting and moving your whole life. I'm just here to make you better. That's it. I'm not here to do anything other. I'm not here to tell you how to work out. I'm not here to tell you none of that. I'm here to bring a little bit of engineering perspective to human movement because there are some complexities and some illusions involved to make you better. So I think most of the time the students that don't perform as optimal as they want are like, I already know this stuff. I already know flexion. I already know extension. Does that make sense? So I'm trying to check my ego at my door every day. Let's try to check our egos at our door. And let's next week, let's do some magic. Let's set an all-time record for the first test. You ought to go